Switching from standard form to trig form. So what if I have a complex number in standard form and I'd like to rewrite it using our new trig form? How can I do that? It basically just boils down to drawing a reasonable picture and then using those polar relationships. So let's take a look at this first example. I have the complex number z equals -2 plus 2i. If I wanted to sketch that in the complex plane, the number would end up right here. My real part was -2 and my imaginary part was +2. In order to rewrite this in trig form, I need to know r, the modulus, the distance from the origin to that spot, and theta, the angle from the positive part of the real axis, rotating around so that I'm facing the point in question. Well, as we said, the polar relationships apply, so I'll have r squared equals a squared plus b squared. I know what a and b are, just the -2 and the +2. And so when I work that out, I'm going to get r squared equals 4 plus 4, which is 8. Square root each side. Don't worry about the plus or minus. We're always taking r to be positive. And let's see, 8 is 4 times 2. I can square root the 4 for a 2 on the outside and leaving me with a 2 on the inside. So my r comes out to be 2 square root of 2. How about theta? Well, another polar relationship that we have is tangent theta equals y over x. Of course, in our case, it would be b over a. So that's 2 over -2, which is -1. I'm trying to figure out the angle whose tangent ratio is -1. I am in the second quadrant, so I know the calculator won't really help me directly. But when I see a 1, I know this is an angle I'm familiar with. You can probably already tell just from the picture. If I'm in the second quadrant and the tangent ratio is -1, then I must have a situation like this. Well, this is just a 45, 45, 90 right triangle. If my reference angle is 45 degrees, then of course this fuller angle that I want here would just be 135 degrees, which in radians is 3 pi over 4. So just thinking in terms of the picture and a little bit of basic trig, I end up with theta equals 3 pi over 4. Once I have r and theta, I can write down my trig form. The trig form of this complex number would be 2 root 2, my modulus, parentheses, cosine 3 pi over 4, I'm filling in my argument now, plus I sine 3 pi over 4. And that's the answer. That is the trig form of the complex number. Or, if I wrote it in that abbreviated format, I could simply write 2 root 2 and then cis 3 pi over 4. Okay, let's take a look at a different example. How about z equals 4 plus 3i? Again, I think a quick sketch is helpful. Real part is 4, imaginary part is 3. Here's my r and here's my theta. Well, again, to get the r, just use the polar relationship. R squared equals a squared plus b squared. That'll be 4 squared plus 3 squared. 16 plus 9, that gives me 25. This time it worked out nicely. The r just comes out to be 5. How about theta? Well, I have the relationship tangent theta equals b over a, so 3 over 4. That is not a nice tangent ratio. I'm not going to be able to do this by hand, so I'm going to have to rely on the calculator. And the nice thing in this problem is that I am in the first quadrant, so I know that theta can be found by simply taking the inverse tangent of 3/4. When you go to the calculator, you'll have to pay attention to the directions. Let's say that in this one I'm being asked to give the answer in terms of degrees. Then I would go to degree mode on my calculator, and then I would just type it in. Tangent inverse of 3/4, and it looks like I get about 36.9 degrees. Well, remember, once you have r and theta, you have everything you need to write down the trig form. I'll just use the abbreviated form this time. I'm going to end up with z2 equals 5 cis 36.9 degrees. Example C gives us the complex number z equals 5i. If your complex number lies on either the real axis or the imaginary axis, then finding the trig form is pretty easy. This one doesn't have a real part, so it just goes up here 5. Well, r would just be this distance, and theta, the argument, would just be this angle. I don't really need to work anything out. I can see very clearly that the r would be 5 spaces from the origin to the point. And the theta is obviously 90 degrees, or I'll work in radians this time and write down pi over 2, which means my complex form for this number in the abbreviated format would just be 5 cis pi over 2. And we're done. Thanks for watching.